Here's a quick review of the indicators assignment, the worksheet assignment, whatever you want to call it. First is question. When tested, a solution turns red, litmus, blue. Well, litmus is red in an acid and blue in a base. I've highlighted the D's in the end of acid and red, and I've highlighted the B's in the front of blue and base. So litmus is red in an acid, blue in a base. So if it turns red litmus blue, if it's turning it blue, that means it must be a base. And if it's a base, that must mean that we have more hydroxide ions than hydronium ions. So the answer there is number 3. Number 2, phenolphthalein, pink color in a solution. Well, the only time it's pink is when the pH is greater than 9. This may be an older table M, but it's going to be a little bit higher. pH, so all these ones got to be higher than 9, so it's going to be number 4. Number 3, again, turning litmus red. Now there's blue litmus and there's red litmus. Basically, if you put blue litmus in a base, it's going to turn blue, but it's already blue, so that doesn't really tell you anything. And if you put red litmus in an acid, it's going to turn red, but then again, it's not going to tell you anything. The real difference is when you put blue litmus in a solution and it turns red, that tells you, oh, it must be an acid. If you were to put red litmus in a solution and it turns blue, that means, oh, it must be a base. So red litmus turns red in an acid, doesn't really tell you anything. It just looks like it's wet. So anyway, which solution would turn blue litmus red? That means it's got to be an acid. So we're looking for an acid. Table K and table L are the acids and bases. The only acid here is HCl, hydrochloric acid. Sodium chloride is not, that's a salt. Potassium carbonate, that is a salt. And sodium hydroxide, that is a base. You know it's a base because it has the OH at the end. This has the H at the beginning, so it's an acid. Number 3, if an aqueous solution turns blue litmus red, which relationship exists? Well, you know that if it's blue litmus red, means it's turning the red because of an acid. So if it's an acid, that means you're going to have more hydronium, more H3O plus ions than hydroxide ions. And that's what this is, number 1. The hydronium ion concentration is greater than the hydroxide ion concentration. Remember, the square brackets are read as concentration. A lot of information there. So a 100th molar, 0.01 molar solution of HCl, it's an acid. So it says litmus will be, well, in an acid, what happens to litmus? Right, litmus is red in an acid. So you're looking for the litmus will be red, and one of 3 or 4. And then phenolphthalein. Well, in an acid, what is phenolphthalein? Well, phenolphthalein is colorless when it's below 7 or 8. So it's going to be colorless. So it's going to be, litmus is going to be red, and phenolphthalein will be colorless. So number 3. Number 6, here's a bunch of information. It says we did some experiments and we found that this solution, all right, we put some bromothiamyl blue in it, okay? Then we took another sample of the solution, put thymol blue in it, and then we put another sample of the solution, we put methyl orange in it. And what happened? Well, it says, at what pH would all 3 indicators appear as yellow? Well, bromothiamyl blue is the top one. That is yellow when you're 6.2 or less. So 6.2 or less, there's 6.2 or less. So that's going to be yellow, 6.2 or less. Thymol blue is going to be yellow when it's 2.8 or higher. So here's 2, there's 3, 2.8 is right about there. So 2.8 and higher is going to be yellow. We want to find out when all 3 of these are yellow. Methyl orange is yellow when its pH is 4.4 or higher. So here's 4, 4.4. So 4.4 and higher. So the place where these are all going to intersect, somewhere between 4.4 and 6.2, that is the pH when all 3 of these will be yellow. So you're looking for something greater than 4.4 and less than 6.2. And the only one that meets that criteria is number 3, 4.7. So number 7 is saying an organic compound whose water solution turns litmus red. Well, what does that mean? Well, remember, Litmus is red in an acid, so we have to find something that's an acid. Organic solutions are an acid. We know that when we have a carboxylic acid group, the COOH group at the end of an organic compound. So that is your acid. That's an alcohol. Don't confuse that with a base. That is an alcohol. These are organic compounds. That's benzene and that's glucose or fructose. Number 8, it says a student dissolves a substance in water, tests the resulting solution, and observes that red litmus paper turns blue. Well, if it's turning blue, that means it must be a base. Number 3. Number 9, solution. Which solution, when mixed with a drop of bromothiamyl blue, will cause the indicator to change from blue to yellow. Bromothiamyl blue is going to be blue to yellow. So it's going to go from blue to yellow. All right, so it started out as blue, so higher than 7.6, and it went yellow, so it went below 6.0. So that means you had to have put an acid in there. And the only one that's going to make it change from blue base to red to yellow acid is going to be HCl. Ammonia and sodium hydroxide, 2 and 4, those are both bases as listed on table L. Number 3 is neither a base nor an acid. It's an organic compound with an OH, the hydroxyl group. That is called an alcohol. So number 3 will have methanol will have no change. Number 4 and 2, they're going to keep it blue, but we want to go from blue to yellow, so you have to add an acid, so that's number 1. Again, according to reference table M, what is the color of an indicator methyl orange when it's has pH of 2? Well, methyl orange, 2 would be lower than 3.1, so therefore it would be red. Number 11 says, in which solution will thymol blue appear blue? Thymol blue is down here. Thymol blue is blue when it's 9.6 or higher. 9.6 or higher is going to be a base. Right, so we're looking for a base. Numbers 1 and 3, they are both acids. That's an organic acid because you had the COOH. Number 3 is an acid because it's HCl, hydrochloric acid. Those are both listed on table K. H2SO4 is an acid. That is sulfuric acid found on table K. We need something that's a base. That's that one right there, KOH, potassium hydroxide. Again, another way you could do this one is the old which one's different than the others. Looking at tables K and L, you'll see that numbers 1, 3, and 4 are all on table K, where KOH is found on table L. So that's going to tell you the one that's different. That's the base. Which indicator is yellow in a solution with a pH of 9.8? 9.8. Well, we want it to be yellow. So methyl orange is only yellow when it's 4.4 or higher. Well, 9.8 is higher than 4.4. That would be it. Let's keep going, make sure. Bromothiamyl blue, 9.8 is higher than 7.6. That's blue, so that's not going to be it. Bromocreosol green, that is blue, higher than 4.4. We want it to be yellow. It's got to be 3.8. 9.8 is higher than 4.4, so that bromocreosol green will also be blue. Thymol blue at a pH of 9.8 is going to be higher than 9.6. That's blue. So the only one that's going to be yellow is methyl orange. All right, so number 13 says the table below shows the color of indicators methyl orange and litmus in 2 samples of the same solution. That means they're not mixing the 2 solutions, 2 indicators. So methyl orange is yellow and litmus is red. So methyl orange is yellow, so that means the pH is 4.4 or higher, but litmus is red. So that means these have to be 4.5 or less. So because we're using an old version of table M, this is kind of tough to say. It looks as though it has to be between 4.4 and 4.5. They have since amended this one. I think it's 6.0 now. So see if I can paste that in there. Nope, that's the wrong thing I'm pasting. Delete that. Anyway, it's actually pH of 5. pH of 5 is the correct one. I'm using the wrong table M, evidently. Number 14 says which indicator, when added to a solution, changes color from yellow to blue as the pH of the solution goes from 5 to 8. 5 to 8, bromo creosol green, 5 to 8. 5 is going to be green. 8 is going to be blue. We want to go from yellow to blue. That's not it. Bromothymol blue. Bromothymol blue, 5 is going to be, 5 is going to be yellow. 8.0 is going to be on the other side of that. That's going to be blue. So bromothymol blue is going to be the one that changes from yellow to blue. Litmus is red and blue. There's no yellow in there. Methyl orange is red and yellow. There's no blue in that one. So it can't be those two. It's got to be one of these two. So it's bromothymol blue. And the last question, which indicator is blue in a solution that has a pH of 5.6? It's got to be blue. It's got to be higher than 5.6. Bromocreosol green, 5.4. It's blue. Anything higher would be blue. 5.6 is higher than that. Bromocreosol green looks like the correct answer. Let's keep checking. Bromothymol blue is blue, or bromothymol, when it's higher than 7.6. Well, 5.6 is below that. That would still be yellow. Methyl orange never turns blue, and thymol blue is blue when it's 9.6 or higher. That's got a 5.6, so it's going to be bromocreosol green. Hopefully that helped. If you didn't get any of that or missed some of it, ask me some questions.